Alrighty. Here today we have 5.5. Okay, 5.5 it talks about properties of logarithms. Okay, and I've written some of these here, and you can also go to your e-text, and they'll have them in there also. Okay, we've talked about logarithms, and we'll kind of go through some of them again. But you have a logarithm. It says log base b of 1 is 0, which means any base you use, log base 35 of 1 is always 0. And that's because base to any number, or to exponent of 0, is always 1. Okay, it doesn't matter what the base is. Any exponent of 0, you always get 1. And you have log base b of b is 1. Okay, now in that case, this b, it just means if these two numbers are the same, this is going to be 1, such as log base 30 of 30 is 1. And that's because if I was 30 to the first power is equal to 30. Okay, if these two numbers again the two bases are the same and it has an exponent other than 1, your answer is going to be that x. In other words, log base 30 of 30 to the 5th power has to equal 5. Same thing here. If I have a base 17, log base 17 of 3, the answer is going to be 3, as long as the bases are always meshed up. So let's look at these examples. Log base 2 of power 4. Well, that's going to follow into this one. The bases are the same. The answer is 4. Log base 3 of 3. These two numbers are the same. And basically the same problem. What's the exponent here? The exponent's 1, right? The answer is 1. Log base 4 of 1. Well, that's going to fall into this first one here. Answer, anytime this number is a 1, this has to be a 0. Okay, and then if these numbers are again match up, the answer is 2. So those are some basic log problems. Now, there are a couple log rules. There is one that's known as the log product rule, and then we also have the quotient rule, okay, or the log quotient rule. In the log product rule, okay, you have, if two things here are being multiplied, and usually it might be like 2x or two different variables, you can split those apart by saying log base b of m plus log base b of n. And you split these two things multiplied with an addition. Notice the bases are going to stay the same. Okay, and in the quotient rule, I have two things being divided inside one log. That's going to become log base b of m minus log base b of n. This number has to be the numerator. This number has to be the denominator. Okay, so multiplication gets separated by addition. Division gets separated by subtraction. And what we call this is expansion. Okay, so in other words, they want you to expand this log. Well, what's happening here? Well, it's x times y times z, which means I can expand it by using this rule and using addition. And there's three things, 1, 2, 3, so I need 3 logs. So it's going to be log whatever base it is of x plus log whatever base of it is y, and then plus log base b of z. And so they're expanded out to multiple logs, okay, each using addition because these were all being multiplied. Okay. Now, here I have a couple things being multiplied. I also have a division. Okay, so the first thing we're going to do is we're going to separate the division. And we're going to separate the division by using subtraction. Okay, alright, so we're going to go log, and this is base 10, right, of x minus, and because all of this is underneath, we're going to put parentheses here, log base y z. Okay, now how do I separate yz? Well, that's addition, right? That would be separating like up here. So we still want to expand, so it would be minus log base y plus log of z. All of them have the same base of 10. And then what we have to do is distribute this negative through. This negative goes through to both of them. So it's going to be log base 10 of x minus log base 10 of y minus log base 10 of z. And there we have an expansion using the 3 different letters. Now, if there's only 2 letters, then there's only 2 expansions. Okay? Now, the third log rule is the power rule. And that's saying that if I have log base b of n to some exponent, we can actually bring that exponent in the front, and we get the power is now in front times log base b of n. Now we usually do that step last if it happens, okay, because notice we have these exponents that's going to be there, but before I can do the exponents, because there's multiple ones in here, I have got to separate these guys, okay? And these guys have to be separated first, and they're all being multiplied, so that means it has to be expanded using addition. Log base b of x cubed plus log base b of y squared plus log base b of z to the first. Now I can use this power rule on those 2 exponents and bring them out front. 3 times log base b of x plus 2 times log base b of y plus log base b of z. Because each of these has to come out front. This one that has an exponent of 1, so it really doesn't matter. Alright, so let's look at this one. Here I have a natural log, and I have that division, right? So let's go ahead and separate that. Natural log of y squared square root of z minus natural log of x. Now that's done right there. There's nothing else with it that has no exponent. Okay? But we've got to deal with this guy right here, the square root sign. Remember that the square root of a number or of some value is the same as saying that value inside to the 1/2. A cube root would be z to the 1/3 and so forth. Fourth root would be z to the 1/4. So this is actually the natural log of y squared z to the 1/2. Okay, now how do I separate the y and the z? I got to separate those two, right? Well, I got to do that by addition. So we're going to have natural log of y squared plus natural log of z to the 1/2 minus natural log of x. And then lastly, the power rule. So now the power rule, that's going to come out front, and that's going to come out front of that one. So 2 natural log of y plus 1/2 natural log of z minus natural log of x. And there is my expansion of that. Okay? Now, the rules that we talked about, okay, we'll go back and look at these 3 rules again. Okay, when I make them multiple logarithms, we're expanding. Okay, but the thing is, it can go the other way. We can go from the multiple logs to just 1 log, and that's called condensing. Okay, so what we want to do is condense logs to 1 log. So we're going to actually do the vice versa. We want to get these 2 logs into be 1 log. Okay? First things first, we're going to use power rules. Usually if I see a power here and here, we got to bring them up. Bring them up. Alright, so the first step is going to be log base b of x squared plus log base b of y to the 1/3. Okay? And now remember that this is the same as the cube root of y. And now we're going to condense the addition. The addition will condense down to multiplication. Natural log of b, x squared times the cube root of y. And there's 1 logarithm now. Okay? Alright, so let's look at this one. Alright, so we have this one that has a lot of work that we got to do. So we want to look at see what we need to do here. So let's look and let's see, do we have any powers first? Yeah, got some powers. Okay, we've got this power and we have this power, right? And if you wanted to, you could even make this one here. Okay, but let's say log base b of x minus 2 to the 1/2 minus log base b of y plus log base b of z cubed. Okay, so we have those, but this is what's going to make it a little tricky right here. Okay, it makes it a little tricky at the point of what am I going to do with that negative there? I know it's division. Okay, but let's go ahead, and because there's a 1 here, we're going to make this negative 1 make that a power. It just ends up making things a little bit easier. This is going to be log base b, and we're going to change that to the square root of x minus 2 plus log base b of y to the negative 1 plus log base b of z cubed. Now I have it all in addition, and what I'm going to do is this is going to be log base b of square root of x minus 2 times y to the negative 1 times z cubed. And if you remember our negative exponent rules, those go down. Log base b of y down the bottom, and I'm just going to put the z cubed, the book likes to put the z cubed in front, x minus 2. And that is all inside this one log. A little tricky in a couple of those steps. Okay. Alright, now lastly is let's kind of look at some of the things we know already. Okay, so just a little review. So log base 3 of 27, okay, would be equal to 3, and that's because 3 to what power is 27? Well, that would have to be 3, right? Log base 3 of 81 is 4 because 3 to what power is 81? Well, that would have to be a 4. Okay, so what is log base 3 of 54? Well, 3 to what exponent is 54? Well, if this is 3 cubed is 27 and 3 to the 4th is 81, well then this number here has to be between 3 and 4, right? It's not a whole number though. Yeah, there's no whole numbers in between those. So we've got to figure out how to deal with this. Now, some of your calculators, okay, if they've been updated, you can actually go to the log button, find your log button. Most of you again use this one. Okay, so if I use this one and my log button's right here and I hit it, notice there's no number there. That's always base 10. If I hit this, it's base E, correct? But I want base 3. Okay, some of you might be able to go into your math button, and if you go far enough down, you might actually find another log version. Okay, sometimes they're in different places, but this one does not have it. Okay, so if you don't have a logarithm button, and you'll know it because it'll say log and it'll have a little box right here. Okay, if your calculator does not do that, you're going to have to use what's known as the change of base formula, and a lot of you are going to have to do this. Okay, now the change of base formula, and this works for any of you whether you have it or not, but log of some base of x is going to equal log of x over log of b. Now the base here, you can either use base 10, which is a regular log, which your calculator has, or you can use base E, which is natural log, and I'm going to show you how that works here in a second. Okay, so what happens is, here's my x, this x matches up with this number, okay, this value b matches up with the base that they're giving you. Okay, So, to find the log of base 3 of x, we would do the log of 54 over the log of 3. Or, I could do the natural log of 54 over 3. Natural log of 3. Either way works. Okay? So, what you would do, what you do in your calculator, we're going to erase this, we're going to do log of 54, close the parentheses, divided by log of 3, close the parentheses, and we'll get an answer. Now remember, we said the answer had to be between 3 and 4. What's my answer? Well, that's going to be 3.6309. Remember, we always go 4 decimal places on these. And there's a reason why you go 4 decimal places, because 1 decimal place you won't get close enough. 2 decimal places, you get a little closer to your answer. Okay? Now, I said you could also do it this way, which would have meant natural log of 54 divided by the natural log of 3. And notice I get the same answer. Okay? Now, how would I check it? Well, this means that 3 to that exponent should be pretty close to 54. So 3 to the exponent of 3.6309, and look how close we are. That's pretty close. Okay? In fact, the longer the decimal I use, the closer we get to that. So instead of doing 4 decimal places, if I did 3.63092, look, I get a little closer, I add an extra 9. And if I did 3 to the exponent of 3.6309, let's do 297. And looky there, look, that's even closer to 54. So the more decimal places they use, I actually get closer. But we don't want to have to write a whole lot of decimal places. That's why they figure 4 decimal places is about as close as you probably need to get. Okay? And so that's change of base formula. And that is on your formula charts. Okay? You just have to know how to use it. Okay? And most of you won't need to use it, because I think most of your calculators will not have the little change of log button. Your Inspires do, and you can check and see if your calculator has been updated. So, alright, I hope this helps. Okay?